Hello, we're doing this video and it's about integration by parts. So first I tell you about how to drive the formula, then I do a simple example, and then in another video we do more. So how do we drive the formula? First of all, what is this? We know that there is no rule, product rule for integration, but the product rule for derivative can be reversed somehow. And so let's say we're taking derivative of f of x times g of x, and that's the product rule. And so it would be the derivative of f of x times g of x and plus f of x times derivative of g of x with respect to x. And so what happens is that if I take the integral of all sides, this is what I'm going to get basically. Integral of the first side, and let's switch to red, with respect to x, and then with respect to x, and with respect to x. And so the first one, it was the function was the product of f times g, and I took the derivative of that, and I'm doing the integral. So I'm basically anti-derivating the entire product rule. So here in this case, because it's derivative of derivative respect to x of this entire thing, and I'm finding antiderivative respect to x, I can write one antiderivative in there, and that would be f of x times g of x. And then over here, we have we have this derivative of f of x times g of x, and we're taking antiderivative of that. And then let's write it down. So there are two functions, each are products. Okay, at this point I'm like, what am I supposed to do with this? It's not derivative of the entire thing that I can antiderivative of. What am I supposed to do? It turns out in some cases, and those are the cases that we can use integration by parts, one of these is easier than the other one. So let's say that basically, let's say this one is easier than the other one. It doesn't matter, you can choose f of x and g of x to be whichever you want. So this antiderivative, I can compute that by f of x times g of x minus this entire thing. So it would be f of x d of g of x with respect to x, and dx is going to be f of x g of x minus So this seems like a lot of x's and f's and g and everything. So what should we do to simplify it for our sake? So what people do usually is they choose in here, they choose f to be u, and then g to be u and v, two variables. And then, so what happens here? This is d of v with respect to x dx. That the entire thing is by the differentials. It's going to be dv. And over here you will have d of f dx times dx, and you have g of x. G of x was supposed to be v, and this entire thing is supposed to be du. So the formula becomes basically integral of u dv is equal to uv minus integral of v du. Nice. So this is the formula. Now let's put it in the work right there. Let's try to do this example. Example is integral of x e to the x dx. So what do I do? Let's say that I choose one to be u and the other one to be v. So what I'm trying to do is to use this formula. Integral u dv is equal to uv minus v du. So let's choose one function to be u and the other function dx to be dv and see where we're going with that. So my first choice, because I have some insight in this, is to choose u to be x. So I'm going to choose u to be x and dv to be e to the x dx. And then to find the first term of the formula, I have to find v. So I have to take the antiderivative of the dv, and antiderivative of the dv, basically it's antiderivative of e. So v is antiderivative of ex dx, which is e to the x. Then to do the second part, I need to find du. And du is just the differential of u over here. And du is equal to derivative of x, which is 1, times dx. And now, basically, the formula is telling me multiply u and v. Then subtract that from integral of the second line. So it's going to be x, the integral is going to be x e to the x dx is going to be equal to x times e to the x minus integral of e to the x dx. And this is going to be x e to the x minus e to the x plus c. And so that's how we use the formula to do the formula for integration by parts to basically solve an integral of a product.